Hi all, welcome to this video on in the series of linear programming formulation videos. This is going to be a simple example of a simple minimization problem. Right. So previous two examples that we did were maximization problems. This one is going to be a minimization problem. So here goes. So M&D Chemicals produces two types of products that are sold as raw materials to companies manufacturing bath soaps and laundry detergents. The M&D calls these two products product A and product B. And these two products, the total must be at least 350 gallons. The usually minimum constraints like these happens because you have some sort of contract that you've set up with the company. So you have to produce a minimum amount. So you have to make at least 350 gallons of these chemicals. Now a customer has ordered 125 products of units of gallon A. So again, there you go. So you have to make at least 125 gallons of units of gallon of product A, or 125 gallons of product A, because that's how much a customer has already ordered. So you need a minimum of 350 gallons for A and B. Now this could also be because if you're using a machine, the machine might have some minima for it to work out for you and so on. So whatever reason you have set a constraint saying that you have to make a minimum of 350 gallons of both products put together, and you have to produce a minimum of 125 gallons of A, because that's how much you have to send your customer. The product A requires 2 hours of processing time, and product B requires 1 hour of processing time. And there are 600 hours of processing time available. So whatever chemical processes that needs to go through, they need to happen. Now, M&D's objective is to satisfy all of these requirements at minimum production cost. So unlike the previous problems here, the objective is to minimize your total production costs. And the costs are, it costs $2 to make 1 gallon of product A and $3 to make 1 gallon of product B. And so what we're going to do here is we're going to set up this problem, formulate this problem again. This week, the idea is just to do formulation. So we're going to formulate this problem. We will do solutions later. All right, so here is the formulation. So again, what I'll do is I'll go back to the Word file and we'll go through all the steps one by one. All right, so this was a simple maximization problem. That's the Power Inc. problem. Now, Power Inc. is a company that we're going to keep coming back to with multiple examples through the semester. But so now let's do the simple minimization problem. This is M&D Chemicals. All right. So again, we'll go through the same 3 steps. So step 1 is the decision variables. As if I could type well. Too many unnecessary spaces here. Same here. Step 1 is decision variables. Decision variables. Now there are 2 decision variables here. We have chemical A, chemical B, and we have to figure out how many gallons of A to make and how many gallons of B to make. So I'm just going to use A and B as my decision variables. Again, here, don't just say A is chemical A. Say A is gallons of product A chemical A, manufactured, produced, and B is gallons of product B, produced, right? So here the decision variables are in gallons, right? So that's important to keep in mind. Step 2 again is the objective. The objective function. The objective function here is to minimize production cost. Will be minimize. So this is a cost function of the variables A and B. So minimize the cost with variables A and B. So the cost will be, we know that it costs $2 to make 1 gallon of chemical A, product A, and it costs $3 to make 1 gallon of product B. So 2 times A plus 3 times B, that's the profit function, sorry, the cost function here. And we're going to minimize the total cost, which is 2 times A plus 3 times B, right? Step 3 is, step 3 are the constraints. So the first constraint is, the minimum. So in this problem, unlike the previous problems that we did, it is not very clear. For example, in both the previous problems that we did, you had like 4 departments, and you had to write 1 constraint per department. But here you have to read through the problem fully and not miss any of the constraints. So here you'll notice that it's nicely given to you in bullet points, but in some cases it might not be given to you in bullet points. You have to read the problem and glean the decision variables and constraints and everything from the problem. So we will look at that too. So we will do that. We'll go through many examples in this class. So here, let's go through this. So the first constraint is that you need to produce at least 350 gallons of both the products put together, right? So the total number of gallons that need to be produced is 350. And in this case, A and B are the gallons of product produced. So in the previous case, when you were writing constraint, we had coefficients. The reason why we need coefficients was S is the number of standard bags that you made, but the constraint was about time, the number of hours available. So you had to take S, multiply it with 7/10, which converted into the time required to make standard bags. So total time for standard bags, total time for deluxe bags. So the total time is less than 630 hours. That's what this constraint was. But in this case, the decision variables are directly in gallons. So the total gallons of the mix of both the chemicals that you're making is just A plus B. So total gallons of A plus the total gallons of B have to be at least 350. So you have to make at least 350 gallons of the total, right? So A times B, A plus B is at least 350. So at the least 350. That's my first constraint, right? So let's say total a minimum. You really don't need to write names for this. I'm going to write them out, but you really don't. You just need to list the constraints. Minimum, you know what? Let's just leave it at that. There's no point in searching for names. So A plus B is at least 350. It's probably just easier this way. Okay, A plus B is at least 350. Now the next constraint is you have to produce at least 125 gallons of product A because a customer has ordered 125 gallons of A. You might produce more and be able to sell it, but you have to produce a minimum of 125 35 or 120? 125. You have to produce a minimum of 125 gallons of A. So A by itself has to be greater than or equal to 125, right? So always remember that these constraints are either less than or equal to or greater than or equal to. So the number can be less than 125, for example, here, or it can be exactly 125 that you make. Sorry, number is either greater than 125 or it could be exactly 125. So based upon the type of constraint that you have, the equal to has always got to be there, and you'll understand this when you go through the solution methodology. Right? That's my second constraint, a minimum of 125 gallons of A. Third constraint is the production time. It takes 2 hours to make processing time, 2 hours to process product A, 1 hour to process product B, and you have 600 hours of processing time available. Now this is similar to the constraints that we've written before. So it's 2 hours for A plus 1 hour for B. So you can either write 1 times B or just B is less than or equal to 600 hours. So you have 600 hours of processing time available, and you have to have a minimum of 600 hours. Sorry, maximum of 600 hours. So you cannot exceed the 600 hours of processing time that you have available. Right? And that's it. There are no other constraints right here. So there are only these constraints. Then we have the cost. Nothing else is left over. And there you go. So those are my constraints. Apart from this, obviously, non-negativity. Non-negativity is always going to be a constraint. Now, on homeworks and on the midterm and on the final exam, I am going to have you go through this, where you list all the decision variables, write the objective, write the constraints. Now we will be doing larger problems where the number of decision variables are not just going to be 2, but we can have like 25 decision variables, or sometimes you'll have 60 decision variables or something like that. For large problems like that, I'm not going to have you list all the decision variables, but write 1 or 2 of them to show that you understand what the decision variables are. But you're going to write the decision variable, the objective function constraint, just like I've written here for most of the problems that when you submit something for the midterm and for the final, you're going to do all of that, right? So these are the formulations for the maximization is in the previous case, and here's the minimization, right? So I'm going to save this file. I'm going to save this Word file and upload it on Canvas. I'm going to call it problem formulation. Now the formulation for the furniture problem is already in the PowerPoint file, so I'm not going to go over it. But for these two, I'm going to post the formulation up there, right? Okay. I'm going to formulate maybe 1 or 2 more problems during the synchronous session on Thursday. So if you're able to attend it, please make sure that you attend it, right? If not, make sure that you watch the video for those formulations also. Now this might look simple, but and you have to practice a few times by yourself till you're comfortable with it. Otherwise, you won't be able to work on it on your own. All right, take care.